Welcome back to my YouTube channel. This video is on electricity and some concepts related to electricity. Electricity. So see the basic definition of electricity. Electricity is the flow of electric power or charge. Electricity is both a basic part of nature and one of the most widely used forms of energy. See, electricity is the flow of electrical power. Electricity is the flow of electric power. So later you will be studied what you mean by electrical power. So electrical power is nothing but rate of doing work or the rate at which work is done. The rate at which work is done is called electric power or it is the charge. Electricity is both a basic part of nature and one of the most widely used forms of energy. So we are using electricity widely in day-to-day life. After that we are having a electric circuit. So electric circuit is the continuous and closed path of an electric current. See, the bulb is glowing in your home. So bulb is glowing in your home is the best example for continuous and closed path of an electric current. After that we are having a charge. The physical property of matter that causes it to experience a force when placed in an electromagnetic field. So see the definition of charge. The physical property of matter that causes it to experience a force when placed in an electromagnetic field. Now I will write the SI unit of charge is. The SI unit of charge is. The SI unit of charge is a coulomb. The SI unit of charge is coulomb. See, the international system used to measure the charge is coulomb and its symbol is capital C. So capital C is the SI unit of charge, or you remember the SI unit of charge is a coulomb. Now the charge on one electron. The charge on one electron is, see we are having the charge on one electron. So charge on one electron is 1.6 into 10 raised to minus 19 coulomb. It is the charge on one electron. So this is very important. Charge on one electron is 1.6 into 10 raised to minus 19 coulomb. So therefore after this we are having 1 coulomb is equal to, see the value of 1 coulomb. 1 coulomb is equal to 6 into, see the value of 1 coulomb. The value of 1 coulomb is equal to 6 into 10 raised to 18 electrons. 10 raised to 18 electrons. See once again, yes, SI unit of charge is coulomb. Its symbol is C. The charge on one electron is 1.6 into 10 raised to minus 19 coulomb. 1 coulomb is equal to 6 into 10 raised to 18 electrons. So after this we are having a very important concept, current. Very important concept, current. It is electric current. Electric current is the rate of flow of charge. The rate of flow of charge is called electric current. See, the rate at which charge is flowed in an electric circuit is called electric current. So see, current we are having, the rate of flow of charge is called electric current. And the electric current is denoted by the symbol. Electric current is denoted by the symbol. The electric current is denoted by the symbol. Electric current is denoted by the symbol. Is denoted by the symbol I. So I stands for electric current. I is the electric current. So I stands for electric current. Now, so I'll write current is equal to. So electric current is equal to charge flowing. Electric current is equal to charge flowing divided by time taken. Electric current is equal to charge flowing divided by time taken. So therefore I will write a mathematical expression of electric current. electric current is I. Charge flowing is in terms of Q. That is the net charge flowing in an electric circuit. The net charge flowing in an electric circuit is Q, and divided by time taken is T. So this formula is very important. You remember I equal to Q by T is the formula used to calculate electric current. So see, remember we are having I equal to Q by T is the formula used to calculate the electric current. Now after this we are having a SI unit of electric current. SI unit of electric current. We have already formula. We have the formula I is equal to Q by T. It is the formula of electric current. Therefore, I will write I is equal to, see, charge flowing is measured in coulomb. Charge flowing is measured in coulomb. Divided by time is measured in a second. Time is measured in a second. So therefore, I will write I is equal to coulomb per second. So coulomb per second is nothing but ampere. Coulomb per second is nothing but ampere. So I will write this is a capital A. So this is the symbol used to measure the electric current. See, once again, SI unit of electric current. So we are having a mathematical expression of electric current. The mathematical expression of electric current is I equal to Q by T. Q is measured in coulomb. Time is measured in second. So coulomb per second is nothing but ampere. Coulomb per second is nothing but ampere, and its symbol is capital A. So therefore you remember SI unit of electric current is ampere. After this some values which are related to ampere. So before going to some values which are related to ampere, first we go for the definition of 1 ampere. We go for the definition of 1 ampere. 1 ampere. So see, I will take the formula. We have the formula is I equal to Q by T. I equal to Q by T is the formula of electric current. I want current flowing in electric circuit is 1 ampere. I require here the current flowing in an electric circuit is 1 ampere. So hence I will take here the value of Q is equal to 1 coulomb. Q is equal to 1 coulomb and T equal to 1 second in the above formula. So I am taking Q equal to 1 coulomb and T equal to 1 second in the formula I equal to Q by T. So therefore you will get I equal to 1 coulomb divided by 1 second. So 1 coulomb divided by 1 second is nothing but 1 ampere. 1 ampere. So now see the definition of 1 ampere. The electric current flowing in an electric circuit. I repeat once again. The electric current flowing in an electric circuit is said to be 1 ampere. The electric current flowing in an electric circuit is said to be 1 ampere when 1 coulomb of charge is flowing. When 1 coulomb of charge is flowing in 1 second. So very simple definition we are having. The definition of 1 ampere. So see, the electric current flowing in an electric circuit is said to be 1 ampere when 1 coulomb of charge is flowing in 1 second. When 1 coulomb of charge is flowing in 1 second, then electric current is said to be 1 ampere. So now after this we are having some points to be remembered. That is note. Yes, we are having 1 milliampere. See the value of 1 milliampere. 1 milliampere is 1 into 10 raised to minus 3 ampere. 1 milliampere is 1 into 10 raised to minus 3 ampere. After this we are having 1 microampere. 1 microampere is 1 into 10 raised to minus 6 ampere. Next 1 nanoampere. So see we are having 1 nanoampere. So 1 nanoampere is 1 into 10 raised to minus 9 ampere. After this we are having 1 picoampere. 1 picoampere is 1 into 10 raised to minus 12 ampere. 1 into 10 raised to minus 12 ampere. Next we are having 1 femtoampere. So 1 femtoampere is equal to 1 into 10 raised to minus 15 ampere. So these all values you remember. So up to here you remember 1 picoampere. So this is if you want to remember it, otherwise leave it. So only these values remember. 1 milliampere is 1 into 10 raised to minus 3 ampere. 1 microampere is 1 into 10 raised to minus 6 ampere. 1 nanoampere is 1 into 10 raised to minus 9 ampere. And 1 picoampere is 1 into 10 raised to minus 12 ampere. So these values you remember. So this is about electric current. Now, yes, the device used for measure the electric current. So the device used for measure the electric current is an ammeter. See, the device which is used to measure the electric current is an ammeter. And this ammeter is always connected in a series in an electric circuit. So in electric circuit, always you are connected ammeter in a series. So you are connecting ammeter in a series in an electric circuit to measure the electric current. So remember, the device used to measure the electric current is an ammeter, and which is connected in a series in an electric circuit. After this we are having a very important definition: electric potential. Electric potential. Electric potential. See, it is a positive plate. It is a positive plate. And this one is a negatively charged plate. Negatively charged plate. Yes, see. Now, charge is here. Q is the charge. It is on one end of the plate, which is on one side of the plate. Now, W is the amount of work done. See, W is the amount of work done is required to move a charge from one end of the conductor to another end of the conductor is called electric potential. See the definition of electric potential. Electric potential is the amount of work done, or the amount of work is required. The amount of work is required to move a charge. To move a charge, Q is the charge. To move a Q from one end of the plate to another end of the plate. To move this Q from a positive plate to negative plate is called potential difference. So remember the definition of potential difference. The amount of work done is required, or the amount of work is required to move a charge from one end of the conductor to another end of the conductor is called electric potential. So now, the symbol used to measure the electric power. The symbol used to measure the electric power is, the symbol used to measure the electric power is V. Sorry, the symbol used to measure the electric potential. The symbol used to measure the electric potential, or the symbol used to measure the electric potential difference between the ends of the conductor. Electric potential difference between the electric potential difference between the electric potential difference between the ends of the conductor, between the ends of the conductor is SV. So therefore you remember V is equal to W by Q. Electric potential is V equal to W by Q. That is amount of work done is required to move a charge from one end of the conductor to another end of the conductor. So remember this formula we are having V equal to W by Q. After this we are having SI unit of S potential difference. SI unit of potential difference. SI unit of potential difference. So you are having SI unit of potential difference. So formula we have V is equal to W by Q is the formula used to measure the potential difference. So therefore I will write V is equal to W. Work done is measured in joule. See, work done is measured in joule. So I will write work done is measured in joule divided by charge flowing. Charge flowing is measured in coulomb. Charge flowing is measured in coulomb. So V equal to joule per coulomb. So joule per coulomb is a volt and its symbol is a V. So therefore you remember the SI unit of electric potential or the SI unit of potential difference is a volt, and the device used to measure the potential difference between the ends of a conductor is voltmeter. See, the device is used to measure the electric potential difference between the ends of the conductor is a voltmeter, and which is always connected in a parallel in an electric circuit. We are always connecting a voltmeter in parallel to measure the potential difference between the ends of the conductor, right? So now after this a very important definition, 1 volt. 1 volt. See the definition of 1 volt. Yes, I'll write the formula. We have V equal to W by Q. V is equal to W by Q with the formula used to measure the potential difference. So I'll take here work done is equal to 1 joule. Work done is equal to 1 joule, and charge flowing is 1 coulomb. Charge flowing is 1 coulomb. Then this V is equal to 1 joule divided by 1 coulomb. So 1 joule divided by 1 coulomb is 1 volt. 1 joule divided by 1 coulomb is 1 volt. See, the electric potential difference between the ends of a conductor. The electric potential difference between the ends of a conductor is said to be 1 volt. The electric potential difference between the ends of a conductor is said to be 1 volt. When 1 joule of work is done, when 1 joule of work is done to move 1 coulomb of charge from one end of the conductor to another end of the conductor. See, the electric potential difference between the ends of a conductor is said to be 1 volt. The electric potential difference between the ends of a conductor is said to be 1 volt. When 1 joule of work is done, when 1 joule of work is done to move 1 coulomb of charge from one end of the conductor to another end of the conductor, right? So these things you remember. After this we are having a very important law, Ohm's law. A very important law, Ohm's law. See, Ohm's law. Ohm's law. Ohm's law. So I'll take this is one conductor. It is the conductor. V is the potential difference between the ends of the conductor. V is the potential difference between the ends of the conductor. And for this conductor, applied a battery. You already know battery means it is a combination of cells, and after that we are having plug key. It is closed. Plug key is closed. Now I is the current flowing in this direction. So I is the current flowing in this direction. So battery it is combination of cells, and this is the plug key. So now see statement of the Ohm's law. So Ohm's law states that at a constant temperature, so temperature should be constant here. At a constant temperature, the potential difference between the ends of a conductor is directly proportional to current flowing through it. So very simple statement we are having. Very simple statement of the Ohm's law. First, have to keep temperature is constant, and after that, the potential difference between the ends of a conductor. So V is the potential difference here. V is the potential difference. Potential difference between the ends of a conductor is directly proportional to current flowing through it. So see, we are having V. What did we hear? Potential difference between the ends of the conductor. I is a current flowing. So therefore, at a constant temperature, the potential difference between the ends of a conductor is directly proportional to current flowing through it. So this is the Ohm's law. So I'll write it is a symbolically. I'll write symbolically. So potential difference between the ends of a conductor. So phi is the potential difference between the ends of a conductor is directly proportional to I. See. So this is the yes according to statement. So see, potential difference between the ends of a conductor is directly proportional to current flowing through it. So therefore I'll write phi as it is, and I'll remove directly proportionality sign. I'll remove this directly proportional sign, and in place of directly proportional sign, I'll write proportionality constant R, and this R is known as resistance of the conductor. Very important. So see, at the beginning I written potential difference is directly proportional to current. I removed a directly proportionality sign, and in place of directly proportionality sign, I have written R. So R is a proportionality constant known as a resistance of the conductor. So remember, so therefore we are having P is equal to IR. This is called mathematical expression of Ohm's law. So see, this is the mathematical expression of Ohm's law, or you can write this as IR is equal to SV. IR is equal to V. So therefore R is equal to V by I. R is equal to V by I. This is a resistance of the conductor. So resistance of the conductor is a material or which always opposes to the flow of electric current. Resistance means which always opposes to the flow of electric current. So remember the mathematical expression of resistance of the conductor is R equal to V by I. Next, after this we are having SI unit of resistance. SI unit of resistance. See, the SI unit of resistance. We have R is equal to V by I. See, it is the mathematical expression of resistance. R equal to V by I. So therefore, R I will write as it is. V means potential difference, and potential difference is measured in volt. Potential difference is measured in volt. I is a current which is measured in ampere. So therefore R equal to, I will write V by A. So V by A is a ohm. Therefore the SI unit of resistance is a ohm. See, the SI unit of resistance is the ohm, and its symbol. See, its symbol is like this. So it is the symbol of ohm. Remember, the SI unit of resistance is ohm, and its symbol is like this. So this is a SI unit of resistance, right? After this, we are having 1 ohm. 1 ohm. So see, the definition of 1 ohm. 1 ohm we are having. So first I will take a mathematical expression of resistance. I will take a mathematical expression of resistance. 1 ohm. R is equal to, we are having V by I. It is the mathematical expression of resistance. Yes, you take a V equal to 1 volt and I equal to 1 ampere. I equal to 1 ampere. Then R is equal to, you will get 1 volt divided by 1 ampere. So 1 volt divided by 1 ampere is nothing but 1 ohm. Now see the definition of 1 ohm. The resistance of the conductor is said to be 1 ohm. See, the resistance of the conductor is said to be 1 ohm when the potential difference between the ends of a conductor is 1 volt and the current flowing through it is 1 ampere. So very simple definition, very simple. So definition is here only. In this mathematical expression we are having the definition of 1 ohm. The resistance of the conductor is said to be 1 ohm when the potential difference between the n superconductor is 1 volt. See, I took V equal to 1 volt, potential difference is 1 volt, hence I am telling the potential difference between the n superconductor is 1 volt and current flowing through it, that is current flowing in the electric circuit is 1 ampere, right. So this is the definition of 1 ohm. So kindly for further study you see my videos, that is videos on YouTube, and kindly share it, subscribe it. Thank you for watching.